Hello everyone, this is the first lecture of Clayton series. I welcome you all to this series and today we will be learning about drawing curly arrow mechanisms in organic chemistry reactions. So before getting into these curly arrows, it is better if you know about if a molecule is given, which is the electropositive atom, which is the electronegative atom, and how to locate the lone pairs, how to locate the empty atomic orbitals. These kind of things will help you in finding the correct reaction mechanism. So, what is a curly arrow? A curly arrow shows the movement of electrons from a nucleophile to electrophile. This curly arrow always starts from a nucleophile and ends in a electrophile. Now, our goal is to find out which species can act as the nucleophile and which can act as the electrophile. A nucleophile, sometimes it can be a electron just like a lone pair of electron just like in ammonia, and sometimes it can be a anion, and sometimes it can be a double bond, sometimes it can be a single bond attached to an electropositive atom like lithium. Now, who can act as electrophiles? Electrophiles, they can be sometimes an empty p orbital on an atom just like a boron in boron trifluoride. Sometimes it will be a positive charge which shows the emptiness of the orbital, and sometimes it can be a double bond attached to electronegative atom like oxygen, and sometimes it will be a sigma bond attached to a electronegative atom like chlorine. So the main point that we should remember is that always this electron will flow from a nucleophile to the electrophile. Now we will see some examples. Let's go to the first example. Here you can see boron trifluoride, and we studied that in boron trifluoride, boron is having an empty p orbital. So these electrons will move from here to the empty orbital of boron, and it will give a product like this. Since oxygen donated the electrons, oxygen will be getting a plus charge and boron will be getting a negative charge. In the second example, you can see a negative charge is there, positive charge is here. So this negative charge will attack on this H plus because plus charge shows the emptiness of the orbital. So this negative charge, which is actually electrons, they will move from this nucleophilic center to the electrophilic center. In the third example, here also there is negative charge. So this OH minus ion, what it will do? Here you can see this carbonyl carbon. So in this case, it is little different because first you need to see here there is oxygen which is actually electronegative. So this bond will be shifted to this oxygen because oxygen is more electronegative. This electron will be pulled towards the oxygen. So there will be a polarization like this. There will be a slight negative charge. There will be slight positive charge. So because of this polarization, this negative charge will attack onto this positive center, and it will leads to a product like this. Now let's move into the fourth example. Here you can see, as in the case of oxygen, bromine is also an electronegative element. So this bond will be shifted towards bromine. So hydrogen will be getting a partial positive charge, and to this positive center, this electron density present in the double bond will be shifted. So the electrons from here will be moving towards the slightly positive hydrogen, and it will be giving a product like this. Here positive charge because the bond is broken from this side. Why? Because there is stability. In the case of secondary and tertiary carbocations, tertiary carbocation is more stable. That's why the bond is broken from this end and not from this side. Now, next one, you can do it on your own. In this here, you can see phosphorus. Phosphorus will be having the lone pair, and iodine, it is an electronegative element. So, you can think of from where to where the electrons will flow and the arrows. So, thanks for watching, and comment, subscribe and share for more videos. Thank you.